The International Space Station is a space station, or a habitable artificial satellite, in low Earth orbit. Its first component launched into orbit in 1998, and the ISS is now the largest artificial body in orbit and can often be seen with the naked eye from Earth. The ISS consists of pressurized modules, external trusses, solar arrays, and other components. ISS components have been launched by Russian, Proton and Soyuz rockets as well as American space shuttles. The ISS serves as a microgravity and space environment research laboratory in which crew members conduct experiments in biology, human biology, physics, astronomy, meteorology, and other fields. The station is suited for the testing of spacecraft systems and equipment required for missions to the Moon and Mars. The ISS maintains an orbit with an altitude of between 330 and 435 kilometers by means of reboost maneuvers using the engines of the Zvezda module or visiting spacecraft. It completes 15.54 orbits per day. ISS is the 9th space station to be inhabited by crews, following the Soviet and later Russian Salyut, Almaz, and Mir stations as well as Skylab from the US. The station has been continuously occupied for 70084799699910000 15 years and 76 days since the arrival of Expedition 1 on the 2nd of November 2000. The station is serviced by a variety of visiting spacecraft. Soyuz, Progress, the Automated Transfer Vehicle, the H-2 Transfer Vehicle, Dragon, and Cygnus. It has been visited by astronauts, cosmonauts and space tourists from 17 different nations. After the U.S. Space Shuttle program ended in 2011, Soyuz rockets became the only provider of transport for astronauts at the International Space Station, and Dragon became the only provider of bulk cargo return to Earth services. The ISS program is a joint project among 5 participating space agencies: NASA, Roscosmos, JAXA, ESA, and CSA. The ownership and use of the space station is established by intergovernmental treaties and agreements. The station is divided into 2 sections, the Russian orbital segment and the United States orbital segment, which is shared by many nations. As of January 2014, update, the American portion of ISS was funded until 2024. Roscosmos has endorsed the continued operation of ISS through 2024, but have proposed using elements of the Russian orbital segment to construct a new Russian space station called orbit.Its. On 28 March 2015, Russian sources announced that Roscosmos and NASA had agreed to collaborate on the development of a replacement for the current ISS. NASA later issued a guarded statement expressing thanks for Russia's interest in future cooperation in space exploration, but fell short of confirming the Russian announcement. Purpose. According to the original Memorandum of Understanding between NASA and Rosaviacosmos, the International Space Station was intended to be a laboratory, observatory and factory in low Earth orbit. It was also planned to provide transportation, maintenance, and act as a staging base for possible future missions to the Moon, Mars and asteroids. In the 2010 United States National Space Policy, the ISS was given additional roles of serving commercial, diplomatic and educational purposes. Scientific research. The ISS provides a platform to conduct scientific research. Small unmanned spacecraft can provide platforms for zero gravity and exposure to space. But space stations offer a long-term environment where studies can be performed potentially for decades, combined with ready access by human researchers over periods that exceed the capabilities of manned spacecraft. The station simplifies individual experiments by eliminating the need for separate rocket launches and research staff. The wide variety of research fields include astrobiology, astronomy, human research including space medicine and life sciences, physical sciences, materials science, space weather, and weather on Earth. Scientists on Earth have access to the crew's data and can modify experiments or launch new ones, which are benefits generally unavailable on unmanned spacecraft. Crews fly expeditions of several months' duration, providing approximately 160 man-hours per week of labor with a crew of 6, to detect dark matter and answer other fundamental questions about our universe. Engineers and scientists from all over the world built the Alpha Magnetic Spectrometer, which NASA compares to the Hubble Space Telescope, and says could not be accommodated on a free-flying satellite platform, partly because of its power requirements and data bandwidth needs. On 3 April 2013, NASA scientists reported that hints of dark matter may have been detected by the Alpha Magnetic Spectrometer. According to the scientists, the first results from the spaceborne Alpha Magnetic Spectrometer confirm an unexplained excess of high-energy positrons in earthbound cosmic rays. The space environment is hostile to life. Unprotected presence in space is characterized by an intense radiation field, high vacuum, extreme temperatures, and microgravity. Some simple forms of life called extremophiles, including small invertebrates called tardigrades, can survive in this environment in an extremely dry state called desiccation. Medical research improves knowledge about the effects of long-term space exposure on the human body, including muscle atrophy, bone loss, and fluid shift. This data will be used to determine whether lengthy human spaceflight and space colonization are feasible. As of 2006, data on bone loss and muscular atrophy suggest that there would be a significant risk of fractures and movement problems if astronauts landed on the planet after a lengthy interplanetary cruise, such as the 6-month interval required to travel to Mars. Medical studies are conducted aboard the ISS on behalf of the National Space Biomedical Research Institute. Prominent among these is the Advanced Diagnostic Ultrasound in Microgravity study, in which astronauts perform ultrasound scans under the guidance of remote experts. The study considers the diagnosis and treatment of medical conditions in space. Usually, there is no physician on board the ISS, and diagnosis of medical conditions is a challenge. It is anticipated that remotely guided ultrasound scans will have application on Earth in emergency and rural care situations where access to a trained physician is difficult. Microgravity: the Earth's gravity is only slightly weaker at the altitude of the ISS than at the surface, but objects in orbit are in a continuous state of free fall, resulting in an apparent state of weightlessness. This perceived weightlessness is disturbed by 5 separate effects. Drag from the residual atmosphere. When the ISS enters the Earth's shadow, the main solar panels are rotated to minimize this aerodynamic drag, helping reduce orbital decay. Vibration from movements of mechanical systems and the crew. Actuation of the onboard attitude control moment gyroscopes. Thruster firings for attitude or orbital changes. Gravity gradient effects, also known as tidal effects. Items at different locations within the ISS would, if not attached to the station, follow slightly different orbits. Being mechanically interconnected, these items experience small forces that keep the station moving as a rigid body. Researchers are investigating the effect of the station's near-weightless environment on the evolution, development, growth and internal processes of plants and animals. In response to some of this data, NASA wants to investigate microgravity's effects on the growth of three-dimensional, human-like tissues, and the unusual protein crystals that can be formed in space. The investigation of the physics of fluids in microgravity will allow researchers to model the behavior of fluids better. Because fluids can be almost completely combined in microgravity, physicists investigate fluids that do not mix well on Earth. In addition, an examination of reactions that are slowed by low gravity and temperatures will give scientists a deeper understanding of superconductivity. The study of materials science is an important ISS research activity. with the objective of reaping economic benefits through the improvement of techniques used on the ground. Other areas of interest include the effect of the low-gravity environment on combustion, through the study of the efficiency of burning and control of emissions and pollutants. These findings may improve current knowledge about energy production, and lead to economic and environmental benefits. Future plans are for the researchers aboard the ISS to examine aerosols, ozone, water vapor, and oxides in Earth's atmosphere, as well as cosmic rays, cosmic dust, antimatter, and dark matter in the universe. Exploration. The ISS provides a location in the relative safety of low Earth orbit to test spacecraft systems that will be required for long-duration missions to the Moon and Mars. This provides experience in operations, maintenance as well as repair and replacement activities on orbit, which will be essential skills in operating spacecraft farther from Earth. Mission risks can be reduced and the capabilities of interplanetary spacecraft advanced. Referring to the Mars 500 experiment, ESA states that, whereas the ISS is essential for answering questions concerning the possible impact of weightlessness, radiation and other space-specific factors, aspects such as the effect of long-term isolation and confinement can be more appropriately addressed via ground-based simulations. Sergei Krasnov, the head of human spaceflight programs for Russia's space agency, Roscosmos, in 2011 suggested a shorter version of Mars 500 may be carried out on the ISS. In 2009, noting the value of the partnership framework itself, Sergei Krasnov wrote, "When compared with partners acting separately, partners developing complementary abilities and resources could give us much more assurance of the success and safety of space exploration." The ISS is helping further advance near-Earth space exploration and realization of prospective programs of research and exploration of the Solar System, including the Moon and Mars. A manned mission to Mars may be a multinational effort involving space agencies and countries outside the current ISS partnership. In 2010, ESA Director General Jean-Jacques Dordain stated his agency was ready to propose to the other four partners that China, India and South Korea be invited to join the ISS partnership. NASA Chief Charlie Bolden stated in February 2011, "Any mission to Mars is likely to be a global effort." Currently, American legislation prevents NASA cooperation with China on space projects. Education and cultural outreach. The ISS crew provides opportunities for students on Earth by running student-developed experiments, making educational demonstrations, allowing for student participation in classroom versions of ISS experiments, and directly engaging students using radio, video link and email. ESA offers a wide range of free teaching materials that can be downloaded for use in classrooms. In one lesson, students can navigate a 3D model of the interior and exterior of the ISS, and face spontaneous challenges to solve in real time. JAXA aims both to stimulate the curiosity of children, cultivating their spirits, and encouraging their passion to pursue craftsmanship, and to heighten the child's awareness of the importance of life and their responsibilities in society, through a series of education guides. A deeper understanding of the past and near-term future of manned spaceflight, as well as that of Earth and life, will be learned. In the JAXA Seeds in Space experiments, the mutation effects of spaceflight on plant seeds aboard the ISS is explored. Students grow sunflower seeds which flew on the ISS for about 9 months as a start to touch the universe. In the first phase of Kibo utilization from 2008 to mid-2010, researchers from more than a dozen Japanese universities conducted experiments in diverse fields. Cultural activities are another major objective. Tetsuo Tanaka, director of JAXA's Space Environment and Utilization Center, says, "There is something about space that touches even people who are not interested in science." Amateur radio on the ISS is a volunteer program, which encourages students worldwide to pursue careers in science, technology, engineering and mathematics through amateur radio communications opportunities with the ISS crew. ARIS is an international working group, consisting of delegations from 9 countries including several countries in Europe as well as Japan, Russia, Canada, and the United States. In areas where radio equipment cannot be used, speakerphones connect students to ground stations which then connect the calls to the station. First Orbit is a feature-length documentary film about Vostok 1, the first manned spaceflight around the Earth, by matching the orbit of the International Space Station to that of Vostok 1 as closely as possible, in terms of ground path and time of day. Documentary filmmaker Christopher Riley and ESA astronaut Paolo Nespoli were able to film the view that Yuri Gagarin saw on his pioneering orbital space flight. This new footage was cut together with the original Vostok 1 mission audio recordings sourced from the Russian State Archive. Nespoli, during Expedition 26-27, filmed the majority of the footage for this documentary film, and as a result is credited as its director of photography. The film was streamed through the website firstorbit.org in a global YouTube premiere in 2011, under a free license. It was the first music video ever to be filmed in space.